Hello everyone, a very warm welcome to this video. In this video, we are going to talk about HDFS and MapReduce deeper dive. So we've already covered HDFS, MapReduce and YARN. In this video, we are going to basically go slightly deep into the way HDFS works and slightly deep into the way MapReduce works. So let's get going. So first we'll talk of HDFS. HDFS is a file system that's developed in Java and it's based on Google's GFS. The biggest ability that HDFS has is it provides you storage on hardware that is industry standard or commodity hardware and gives you replication. It works optimally with less number of large files. Now, the larger the files, the less the lookup for the name node and the better performance name node would give us. Not optimized for random reads, and files in HDFS are write once, and once it's in HDFS you can't edit it. It's also called worm, write once, read many. How does HDFS really work? Files are generally split into blocks of 64 to 128 MB. Data is spread across the cluster with a replication factor of 3. It's the name node that keeps track of all the blocks, and for Hadoop cluster to be accessible, name node has to be up all the time. Now, to ensure that name node is protected, there is one more daemon called as secondary name node, and that secondary name node basically protects the name node. There is a separate chapter on secondary name node and high availability, and we'll be talking about high availability in that particular video. What are few most important points for HDFS? Files are split into blocks of 64 to 128 MB, but if a file is smaller than that, it will only take that much space. What I'm trying to say is that if the file is 4 MB, it will only take 4 MB block, it will not be 64 MB. And when the client is reading the file, it basically gets data from everywhere and integrates the whole file. Let's go slightly deep and look at how files are stored. So when you write data to HDFS, the file is cut into blocks and it is spread across the cluster, and name node keeps the metadata. From the face value, it looks like that when you put data into HDFS, the name node is a bottleneck, but again that's not true, because when you write data, you first contact the name node, where name node will only give you the metadata about where to write the data. The client then connects to the data node. So if you really see how do you write, client connects to the name node to get the block name, and that is to be created. Client then connects to the first data node and starts pushing the data. So basically data is not passing through the name node, and name node is not a bottleneck. So that's how files are written into HDFS. When it comes to reading, exactly same mechanism is followed. So when you basically run the command for reading a file, name node would only give us locations, and it's the client that will connect to the data nodes and get the data. So client talks to the name node to get the details of locations. Once client has all the locations, it connects to the data nodes to get the data using input stream. So again, when you are reading the data, data is not passing through the name node. Few HDFS commands, we will be having a separate video talking about HDFS commands. Few here we'll talk of ls, mkdir. So those are standard Linux commands which can be run on Hadoop file system, and in a separate video we'll go very, very deep into them. So that is HDFS. Now let's take a deeper dive into MapReduce. When a single mapper or reducer is performing processing on a single input split, it is normally referred as task. MapReduce is a programming model for processing large data sets, consists of two phases, map and reduce. We've already covered that. A program normally is set of mapper and reducer. So a single mapper and reducer together would be called as program that gets executed. And when a task is trying to run, it's called as task attempt. So a single mapper and reducer together is called as a job. Mapper or reducer is a task. And while the job is running, if there are 4 failures, the entire job would fail. What exactly is a mapper? Mapper is a program that performs map phase of MapReduce program, takes data in the form of key value pairs, outputs 0 or more key value pairs. Map function is a workhorse that does the job, and map function receives one key value pair at a time. So in the example of 800 students, each mapper got 200 students and map function would go through one by one across all the 200 students. So just to reiterate, assuming an input split or a block has 4 key value pairs, the map function will be called 4 times. Okay? And in most frequent cases, mapper operates on the data that's local to the machine. It's local to the machine. A bit about reducer. Reducer is a program that performs reduce phase of the MapReduce program, takes data in the form of key value pairs, outputs 0 or more key value pairs. It's the reduce function that's the real workhorse that does the job. Reduce function receives one key and all its values pertaining to that particular key. Reducer normally has nothing to do with data locality because wherever the resources are available, reducer would run. So that is about reducer. So mapper takes one record at a time, reducer takes one key and all its values at a time. A quick reiteration, you have data broken into pieces, map is performing that, and post shuffle and sort, all the data gets to reducer finally for consolidation. So a quick note on daemons. Hadoop 1.x typically has 5 daemons: name node, data node, job tracker, task tracker, secondary name node. Hadoop 2.x has 6 daemons: name node, data node, resource manager, node manager, job history server, and node manager. A quick note on daemons. Name node runs on the master and is responsible for storage aspect of distributed storage. Secondary name node maintains logs of data. Data node is where actual blocks are stored. Job tracker runs on the master and is responsible for processing capabilities, and task tracker is the daemon that performs task for processing the data. So quick check: name node for storage master, data node for storage slave, secondary name node for name node backup, job tracker for processing, task tracker slave for processing. In 2.x, name node for storage master, data node for storage slave, secondary name node is for backup of name node, job history server for archival, resource manager and node manager are for resource management. So this is all about MapReduce. So in this section, we went slightly deep into how HDFS and MapReduce works, and that brings us to the end of this particular video, which is HDFS and MapReduce deeper dive.